number 2, we're doing another indefinite integral here. We have 1 over x minus radical x plus 2 dx. So, again, this one, it might not be so obvious what we need to do at the start. Now, obviously, partial fractions isn't going to work here because we have a square root there. But none of your other methods are really going to work here. Trig substitution, we don't have anything squared. That's not really going to help us. Integration by parts, we don't really have a product that would make sense. The only thing that would make sense to even try here, at least at the start, is doing u substitution and just trying to rearrange to see if we get a better form in some way. So the first thing we're going to do is try the substitution just u equals x plus 2. So remember that if you ever do one of those substitutions like this where u is just x plus or minus a constant, what you're doing by that is just trying to rearrange this. The dx and du are always the same, so you never have to worry about, canceling something out. And in this case, x would be u minus 2 by rearranging that. So we could rewrite this integral as u minus 2 minus radical u du. Now, that does look better because our what's under the root is more simple. And now we have 3 terms, and now we really have a quadratic here. So if we rewrote this in the more standard order, you could see that that is a quadratic where our x, or our variable, is actually square root of u, because we have square root of u squared minus square root of u minus 2. So what we need to do here is do another substitution. So this is a little bit tricky in this respect because you don't often have to do this. But in this problem, this is definitely what we're going to want to do. So what we want to do here is we want to say root u is equal to another letter. Let's just pick w here. We'll set that integral up in terms of that, and then when we figure out our integral eventually, we're going to have to do 2 substitutions back. So in this case, it does matter because we don't have just a simple thing going on here. We have to do it for real here. So let's put du here. So our dw is equal to the derivative of this. Now the derivative of a square root is 1 over, let me put du over 2 root u. But in fact, root u is w, so if we rearrange this, du is equal to 2w dw. So let's do our substitution here. So what does our integral become now? So u, if root u is w, u is w squared. Root u is w minus 2. And our du is so you can see this is turning into a much better integral at this point. So finally, before we start evaluating, let's write it in the best way possible. We can put a 2 out front. We have w on top. This is easily factorable as a quadratic. That's going to be w minus 2 and w plus 1. So this is going to work pretty well by doing partial fractions. And it's going to be a very simple partial fractions because we only have 2 terms and they're both linear. So that shouldn't be too bad. So what we're going to have is we're going to do a over w minus 2 plus b over w plus 1 has to be our entire thing here. And remember that when we multiply through by the opposite denominators to get our full term, we always set that equal to the numerator. So we get a w plus 1 plus b w minus 2. And that just has to equal w because that's what our numerator was. So this is a really simple one to do just by plugging in numbers for w. So if w equals 2, that would get rid of the b. we get 3a equals 2. A equals 2/3. You can just do the opposite for b. W equals -1 to get rid of the a. So that would give us -3b equals -1, which means b is equal to 1/3. So we got our a and our b. We have both fractions. So this can be split up into these. And what's even better is that since these are just simple linear factors, when we do the integral of these terms, like, we're just going to get ln of them. No substitutions necessary. Now, the a and b, which are the numerators, those could always just be factored outside the integral because they're just a constant. So these are going to end up being very simple integrals. So what we're going to get here is 2 integral of 2/3 over w minus 2 plus 1/3 over w plus 1. And one more step I'm going to write out before we actually evaluate, splitting them into two different integrals and factoring out the constants. The first one is going to be 4/3 integral of 1 over w minus 2. And then the second one, we still have the 2 and we have 1/3, so we have 2/3. So what started as this has boiled now all the way down to this. And that's going to be much easier to do. Now, since I just erased this, let me make sure we remember what our original substitutions were. U was x plus 2, and w was square root of u, because we're going to need to use those later. So now we just need to evaluate these integrals. But like I said, these are just basic ln's because we don't have any, factors that we would have to worry about if we were doing a u substitution. So our first integral there is just going to be 4/3 ln of w minus 2. And our second one is just going to be 2/3 ln of w plus 1. So now we just have to do our substitutions, put all of our substitutions back how we had it, and we'll have it in terms of x, and then we'll be done. So w was the square root of u, and u was x plus 2, so we can actually kind of just combine those and say that w was the square root of x plus 2, and then just do it all at once. So what we get then is 4/3 ln root x plus 2 minus 2 plus 2/3 ln. This one doesn't need absolute value because it's going to be positive. Root x plus 2 plus 1. So that's going to be our final answer, plus c, because we had an indefinite integral. So this one involved doing two different substitutions, and then a partial fraction decomposition. None of these steps in this one were inherently hard. There's just some work to be done, I guess. But when you see things like this where you have an x and an x plus 2, most of your other integration techniques are not going to work. You're not going to be able to do trig substitution or integration by parts or any of that type of stuff. So your mind should immediately go to u substitution. And it's not beyond problems on a test, obviously, since this was on the test last semester, that you'd have to do two substitutions in the same problem.